Okay, question 4 is our proof by induction question, and in order to prove something by induction we need to first check that the very first case is true, so that's called the base case, and that's going to be when n is equal to 1. So when n is equal to 1, we're just going to have a, which is 3, 1, 0, 1. And checking this one, a to the power of 1 is going to be 3 to the power of 1, a half of 3 to the power of 1, take away 1, 0 and 1, which is 3, a half of 2, which is 1, 0 and 1. So the base case is true. So the next thing we're going to do is assume that it's true for just some random term in random value of n, and we're going to choose k. So we're going to assume it's true. And we're going to check if it's true for the next one after that. Because if we can show that if one term is true and the next term is true, then that shows that they're all going to be true, because we've shown that the first case is true. So what will a to the power of k plus 1 be? Well, that's going to be a to the power of k times a to the power of 1. So just a to the power of k times a. Or we could times it the other way around. This could have been written as 1 plus k. So we could have a to the power of 1 times a to the power of k. And actually this one is pretty much always easier to deal with. I would always recommend you putting the a to the power of k term second and the a term first. So we're going to find out if a to the power of a to the power of k plus 1 is equal to this. So a times a to the power of k is going to be 3, 1, 0, 1 times by 3 to the power of k, a half of 3 to the power of k minus 1, zero, 1. And we're going to multiply this out. So when we multiply it out, we get 3 times 3 to the power of k. We get 3 times 3 to the power of k plus 1 times 0, so just 3 times 3 to the power of k. We get 3 times this term plus 1 times 1. And then we're going to get nothing times 3 to the power of k plus 1 times nothing, so 0. And we're going to get 0 times this, which is nothing, plus 1 times 1, which is 1. So now we need to simplify this. First term is 3 to the power of k plus 1. Second term is the tricky term. What we can do is say we've got half, so we're going to have 3 times a half times 3 to the power of k, which is the same as 3 times 3 to the power of k, which is 3 to the power of k plus 1, we've just done that there, times this half. So that's going to be a half times 3 to the power of k plus 1. We're also going to have a half times minus 3. And then we're going to have this plus 1 at the end. So, still need to sort this term out. We've got 3 to the power of k plus 1. The 0's fine, the 1's fine. we've got half times 3 to the power of k plus 1. This we can rewrite as minus 3 over 2. So we've got minus 3 over 2 plus a whole 1. Minus 3 over 2 plus a whole 1 is minus 1 over 2. And then if we take out that factor of a half, we're going to have 3 to the power of k plus 1. A half times 3 to the power of k plus 1 minus 1, 0, 1, which is exactly what a to the power of k plus 1 will be. So it is true for n equals k plus 1, assuming it's true for n equals k. But we can say it's true for n equals k because it's true for n equals 1. So that's the steps that we take for this proof by induction question. You have to write this conclusion after you've done the proof to get full marks. If you stop here, you won't get full marks. You'll only get 5 of the 6 marks. If you know you've done it wrong, they won't give you this mark. They won't give you the conclusion mark unless you've got it all right up until then.